Okay, here we go. Hello, everybody, and welcome to this week's Future in Space Hangout, sponsored by the American Astronautical Society. And this is your place to learn about the latest cutting-edge technologies that will get humans into space, as well as keeping an eye on the future of space astronomy. My name is Tony Darnell from deepastronomy.space, and I want to welcome everybody watching live, as well as those of you watching after the stream is over, because you guys are also an important part of these viewing audience as well. And you can interact with our guest today by asking questions, which are on the live chat, which I'm looking at now, and I already see Peter Q, Andrew Planet, John Suffel, a lot of the regulars here ready to ask questions on the YouTube live chat, but you can also do it on our Discord server, and there's a link to that in the description box of this video, so I invite you to go there. I'm also got that live on my other computer, so and that is where you can chat 24/7, so I highly recommend you join our Deep Astronomy Discord server. So I still check both of these things after the chat is over, or the live stream is over, so I can ask. All right, I'll try to answer your questions myself after we're done. So this week we're going to be talking with members of a team that NASA has that are designing a technological gateway near the moon. Now, last year, NASA announced that it would like to build something near the moon where astronauts will build and begin testing the systems needed for challenging missions to deep space destinations, including Mars. Now, the area of space near the moon is important because it offers a true deep space environment that will allow us to gain experience for human missions that push farther into the solar system. And it will also provide access to the lunar surface for robotic missions, it'll also have the ability to return to Earth if needed. That would be in a matter of days rather than weeks or months. So NASA's Gateway will have two phases. Phase 1 will use current technologies and allow us to gain experience with extended operations farther from Earth than previously completed. And these missions enable NASA to develop new techniques and apply innovative approaches to solving problems in preparation for longer duration missions from Earth. And Phase 2 will confirm NASA's capabilities built for humans that can perform long duration missions beyond the moon. And for those destinations farther into the solar system, including Mars, NASA envisions a deep space transport spacecraft. And so today we will go into detail about this gateway with Nicole Herrmann and Ben Bussey, both from NASA headquarters. And let me pull them up. So welcome, guys. Welcome to our little hangout here.
Hi, thanks for having us.
Okay, now we have set up slightly different here today. Both Nicole, and Nicole, NASA Nicole and as well as Ben are both in the same shot, and they're down below. Nicole's on the right, or on my left, and Ben is on the right. So, hi guys, welcome, and also my co-host right next to me, Dr. Harley Thronson from NASA's Goddard Space Flight Center, who's going to introduce these hangouts to us. Hi, Harley, and welcome.
Great. Hi, good afternoon, or whatever time people are watching. Good to have you here. And for many of the folks in the audience, you're going to hear a great deal about this for the first time, although this is a capability. The Gateway is a capability that various folks have been speculating on, advocating for almost 2 decades. But just as Tony said, beginning about 2 years ago, NASA strategic planning folks, some of whom are going to be talking with you all today, began to take this took this challenge very seriously and have started to put investment, design. Industry has become involved in it. So this is a very exciting next step into space, which our two guests, Nicole and Ben, will be talking about. So they're queued up. They are ready to go. So let's hand it off to them. And also, we asked them each to give a little bit of a personal professional bio to begin.
All right, go ahead. You want to start with that, guys, and then we'll start with your slides?
Sure.
Okay.
So I'm Nicole Herrmann. Right now I'm serving as the Gateway Integration Manager at NASA headquarters, which is kind of a silly NASA way of saying Chief of Staff for Gateway. I've been at headquarters for about 11 years. I started as an intern and have been supporting over the years exploration architecture activities and development and strategic planning work I recently completed a master's in systems engineering at George Washington University, and I'm very excited to talk to you all today.
Hi, and I'm Ben Bussey. I'm the Chief Exploration Scientist in NASA's HEOMD. And one of my roles is to think about the science utilization of the Gateway, as we'll talk about. And my background is lunar science. I have a PhD in planetary geology. Before coming to headquarters, I was the principal investigator of the mini-RF radar currently flying around the moon on NASA's Lunar Reconnaissance Orbiter.
All right, great. Well, my understanding is you guys kind of put together a little story for us to tell with this Gateway project. So I'll let you go through your story, and then we will ask questions. And I'm looking, by the way, already seeing a lot of them here. So I'll keep those queued up questions. Keep your questions coming, and I will get to them as soon as they finish their little thing here. Okay, whenever you're ready. I've got the first slide that you sent queued up and ready to go.
Okay, great. Yeah, and feel free to jump in with any questions if you feel like it makes sense.
Okay.
As we're walking through it. So if you want to go to slide 2 with the Space Policy Directive 1.
Okay, got it.
Okay, so I think as many of you know, back in December 2017, the administration released their Space Policy Directive 1, which states that NASA should lead an innovative, or the U.S. should lead an innovative and sustainable program of exploration with commercial and international partners to enable the human exploration across the solar system. And then beginning with missions in LEO, the United States is going to lead the human return to the moon for long-term exploration and utilization in deep space. So followed by missions to Mars and other destinations. And so essentially the goal of Space Policy Directive 1 is to have the US lead the global effort to expand human presence beyond LEO. Next slide.
Mm-hmm. Okay.
And so NASA's executing this exploration campaign strategy kind of in an incremental and phased approach. And so this starts from progression of activities in low Earth orbit on the space station, as well as with our commercial partners in LEO. And so gaining that operational experience, extending mission durations in LEO, and then advancing those systems and operational capabilities into cislunar space, and then ultimately onto the lunar surface. And then also gradually transitioning towards missions beyond the Earth-Moon system as our capabilities, our expertise, our systems, we build our infrastructure, and as we become more confident in our operational capability in deep space. Next slide.
Mm-hmm.
And so NASA and human spaceflight has been in organizing and kind of governing its exploration work around these what we call key strategic principles. Folks that have seen presentations and some of our senior leadership and public speakers before have seen these key strategic principles that we try to scope the work that NASA is doing within these principles to make sure that what we're building and working toward is a sustainable exploration program. And so we use our development activities and mission planning to make sure that they're aligned and guided by the principles. I won't walk through all of them, but I think what's kind of helpful for this discussion is to use those kind of in the context of how we're developing and building the Gateway. So, for example, fiscal realism is supposed to convey that anything that we do should be implementable within the buying power of current budgets. And so, as that relates to Gateway, we need to make sure that all plans for implementation fit within our current budget horizon, but that we're also seeking partnerships, domestic and international, to offset some costs for development and to also make sure that we're being fiscally responsible. Scientific exploration, for instance, as it relates to Gateway, as we're developing the Gateway, we want to actively seek input from our broader science community, and Ben will talk a little bit more about that later, on how we can utilize the Gateway to enable new science, new exploration, but also make sure at the same time that we're building those types of requirements into the Gateway system as we develop. Another example, global collaboration and leadership. So in addition to our U.S. commercial partners that we are working with to develop concepts for the Gateway, we're also actively working with the international community and our ISS partners to evaluate different approaches for implementation and different configurations, and looking at international capabilities that can be used for a buildup of the Gateway in cislunar space. And then finally, another example, continuity of human spaceflight. So we want to make sure that we, over the next few years, while we're advancing our exploration systems testing on the space station, and we continue to conduct important research,
and it's a real foodie festival, so we have amazing
feedback.
banquet meals, and chefs come, and you go and have
phenomenal.
I don't know what's happening.
What's
Hi. Are you guys seeing what we're seeing?
what's
Yeah.
that?
Oh, it is? It's your sister. It's Ben's sister.
I may have sent them the wrong link.
Are you?
How do I leave?
Joey, you need to mute.
Also, she linked in via the.
What happened? Oh, look at that.
Sorry, I sent the wrong link.
Close.
So somebody's
You gotta
actually
love
joined
this
the
guy.
yeah, that's the link you joined. There we go. There we are. Okay.
My fault.
Okay.
Live TV.
Yeah, the YouTube link is the one you want to share. She actually joined the Hangout. So okay. So we are back. So I had the
We're still on the principal slide
strategic principles. Right. There you go. I had also gotten us a little bit ahead, but never mind.
So continuity of human spaceflight. It's important that while we are we're advancing toward the first exploration missions, the first launches of SLS and Orion, that we're continuing a strong presence in LEO, that we continue to advance our exploration systems testing on the space station where it makes sense, and continue, a regular cadence of missions in LEO as well as cislunar space. Next slide.
Okay. All right.
So the gateway configuration with all the colors. So over the last few years, there have been several analysis cycles ongoing within NASA, with our domestic partners, with our international partners. And through those analysis cycles, we've been able to tease out some of the best concepts for gateway implementation that meet strategic objectives, NASA goals, US objectives, meet our policies, and the configuration that we have baseline and that we're currently working toward is the one that you're seeing on the screen. And so I'm just going to start from left to right and walk through each module of the gateway and what its role is in the system. So the first element on the left, that's the power and propulsion element. So the PPE is the power and propulsion. It provides transportation for the gateway in between cislunar orbits, and then it also provides the ability to perform orbital maintenance. It'll provide attitude control for the gateway, and it'll also provide communications to and from Earth, space-to-space communications, space-to-lunar communications, and it can also support astronaut EVA comm. And it'll also deliver some of the systems that are necessary for deep space navigation, as well as docking and refueling. The next module is the European, it's called ESPRI, that's an acronym for European System Providing Refueling Infrastructure and Telecommunications. And so that's a structure that has a lot of different functions. It serves as a science airlock to facilitate experiments in deep space, but it's also going to have some augmented communications capabilities, some fuel storage and refueling capability for the gateway, and it'll also have external payload capacity. The next module is what we're calling the US utilization module. And so this is a small pressurized volume that will be launched integrated with the ESPRI, and it'll provide for early utilization of the gateway as early as 2023. And so some of the key functions that the utilization module will have include additional docking ports. It'll have the ability to accommodate internal and external payloads, external robotic interfaces, thermal and power systems. So a lot of additional habitation capability. And then next you'll see we have two habitable volumes. And so we have two habitation elements. The first one in the stack is the one that's going to be internationally provided. And so, like I said, we've been working with our international and domestic partners. And so our international partners would like to work with us on developing one of the habitat modules. And so with that, in addition to the blue habitat module that looks like it's half hard structure and the other half expandable, that's because we're still working with our industry to determine, which implementation of the habitat and the structures will go with for the configuration. But across those two habitation modules, we'll have the functional capability, and it'll be distributed across those, as well as the utilization element to support kind of full crew and life support needs. And then we have logistics modules. And so logistics modules, those will deliver crew consumables and cargo resupply, and it'll enable extended mission durations. It could provide additional science utilization, technology demonstration capabilities, and then other types of outfitting and supplies that might be necessary for missions, extending the longer missions in cislunar space. And so the cadence of that will really just be determined and driven by mission needs. Then we have a robotic arm. you'll see, I think that is F. And so this provides the functionality of deploying and retrieving payloads, berthing robotic spacecraft, and then it'll also be able to provide the gateway with contingency maintenance and also crew translation if necessary. And then finally, we have an airlock module. And so the airlock will provide the gateway ultimately with the capability to enable EVAs, as well as the ability to have additional docking elements, additional refueling, observation ports, and then science utilization as well. And then you'll see also the Orion as the vehicle that will be delivering the crew to the gateway initially. And so that will dock on the end of the gateway to provide the crew. And then also, oh, sorry, go ahead.
Yeah, I was going to say you got a nice little comparison there in the lower right.
Yeah. And so we put that in there too, because I think that there was a misconception, I think, or sometimes, we get the question, are we just building another space station around the moon? And so as you see, it's a much smaller capability. It's a smaller system. And so, we're trying to build up the infrastructure. Like we said, when we started and what you mentioned in the intro, that we want to build this operational capability and not deploy a permanently crewed station. So the gateway will be primarily uncrewed and primarily an autonomous system. And initially the crew will only be there for 30 days once per year as we build up that crew time and the crew stays.
Well, on this topic, let me go ahead and get Dan Heiberg's comment in here, or question in here, because I think it's relevant to this slide. He's saying, he's asking, couldn't you just relocate the space station to the moon? It might be cheaper than building a whole new station. Is that possible?
So orbital mechanics is not my specialty, but go ahead if you want to take it.
So there's two reasons. We actually get that question quite a lot. There's two main answers why that's not the right thing to do. The first, as Nicole said, is it actually takes a lot of energy to actually move the station to the moon from the Earth, but that probably isn't the best answer. The best answer is the space station is in a particular thermal environment. It goes around the Earth every 90 minutes. It spends 45 minutes where it sees the sun, followed by 45 minutes where it's in shadow. To try and put it around the moon, you would have to design the thermal system, totally differently. So the thermal design is one reason. It also a lot of mass that you'd have to move to the moon. And then the third point is, as Nicole showed on the third slide, we still have useful things that we're doing on station and that we want to continue to do in low Earth orbit. So we want station there to do these valuable things.
So this is in conjunction or concurrent with the ISS then?
Yes.
Okay.
Correct. And another point, we want to gain the expertise and the operational capabilities to build up the space infrastructure. And so gaining that expertise, rendezvous and docking and those types of capabilities that you want to learn how to do in a deep space environment are things that we are using the gateway for as well.
And that's a good extra point. So that the space station is protected by the Van Allen belts from a radiation environment. You would need a different design as the gateway will have around the moon where you're in deep space. It's a very very different space environment.
Okay, and while we're on a couple of questions, let me get Larry Keeses in. He's asking, do any of these modules provide 1G?
No, it's all essentially microgravity. Right now, there aren't any plans for a whole module to provide any form of fractional gravity. You can imagine that might be an experiment within one of the modules that the life sciences folks would like to do. But there isn't, if you like, a fractional 1G module.
Okay. Do you want to pick up where we left off here? I think we got.
Sure.
Okay. So the last one I showed was that gateway in the upper left.
Yeah, we can go on to slide 6. We can
Okay.
probably. So that's just a quick. The power and propulsion element, as I mentioned, is going to be the first element launched for the gateway, and so that will be launched in 2022 on a commercially provided vehicle. And I think I covered most of the capabilities of that. So we can actually go on to the next slide, development partnerships.
That's up.
So over the last 4 years, as I mentioned, we've been investigating various implementation approaches and development approaches with U.S. industry partners through our next step habitation development activity. And we've also, as I mentioned, began initial discussions with our ISS partners as well. But as it relates to next step, in 2015 and 2016, in phase 1 of this activity, NASA began looking at how to leverage commercial partnerships to look at how we could enable habitation needs from LEO all the way through development and testing of a Mars-class habitation system. And so we are now in 2018 in the phase 2 of Next Step. And in this phase, NASA selected 6 companies to move from phase 1 and continue their concept refinement for a cislunar gateway. But also in phase 2, the companies were asked to develop ground prototype modules by the end of phase 2 for ground testing. And so we envision that those ground prototype testing to begin in early 2019. So we'll start receiving some of our habitat prototypes from the partners you'll see on the screen here. And so we have Lockheed Martin, who's going to be doing their testing at Kennedy Space Center, and they're looking at refurbishing their heritage hardware from the space station. Orbital, now Northrop, is using their capabilities and with their cargo activities, and they'll be doing their habitat prototype testing at Johnson Space Center. Bigelow Aerospace is looking at expandable habitats, and they're going to be doing their testing in Vegas at their facility.
And let me just point out, I just want to interrupt you, Nicole, and point out to Raj Luthra, he had a question. Will there be a Bigelow expandable habitat module used on the gateway? And there you go. Okay, go ahead. Yeah. I just wanted to point that out to him.
No, that's a great question. So on the slide that we showed with the gateway configuration with all the colors, the domestic habitat, it was split. It kind of looked like, we call it a Frankenhab. Half of it looked like a hard structure and half of it looked like an expandable habitat. That's because, as you see here, we've got 6 partners that are investigating various implementation approaches for what the habitat structure could look like. And so we have not gotten far enough in our analysis to determine which configuration we'll ultimately use for implementation, but it's being considered as part of our next step activities.
Cool.
And then, so Boeing will be testing their prototype at Marshall Space Flight Center in Huntsville. And then we also have Sierra Nevada, who will be testing at Johnson Space Center as well. And then also NanoRacks, which is looking at converted upper stages, and they'll be testing at Marshall Space Flight Center as well.
Let me just point out, I lived many, many years in Louisville, Colorado, and I had no idea that these must be brand new businesses there. I mean, they're just down the road from Ball Aerospace in Boulder, so that's cool. Louisville. Right. It's not Louisville, folks. It's Louisville. I know. You got to live there. You got to live there to know. Okay, go ahead.
Okay, so I'm going to toss it over to Ben.
Okay.
And I've got a few slides now to talk about what we're thinking about regarding science utilization for the gateway. And if you go to slide 8, the question that comes up a lot is what orbit will the gateway be in? And this will be in something called a near rectilinear halo orbit, which is an elliptical orbit where perihelion, or the closest approach to the moon, will be over one of the poles, and we can pick which pole, and it'll be about 1,500 kilometers over the pole. And then apollune, the furthest distance, will be over the other pole, and that will be about 70,000 kilometers. And this is an orbit that's been picked. It facilitates access. There are different launch vehicles that can reach this orbit. It's a proper deep space environment. We're looking at how this orbit can help surface operations for the moon. It provides constant communications for the Earth, and we think the opportunity to do some good science. Then the next one, slide 9, this chart kind of summarizes how the gateway will be used. So I guess some key facts is, again, to come back to the comparison with space station, station has been permanently occupied by a crew for many years now. People should think of the gateway more as an untended platform that is crewed occasionally. And initially, we're thinking of a crew of 4 visiting the gateway once a year for anywhere in the 30 to 90 day range. And then for the rest of that time, the gateway will be uncrewed. And so from a science utilization perspective, there'll be experiments that you need the crew there to interact with, but also most of the time you're just going to have science experiments either bolted onto the outside doing remote sensing or inside. The gateway can also provide communications relay to CubeSats in the area, or lunar CubeSats, or even to landers on the lunar surface. So it actually opens up a communication capability for far side landers on the side of the moon that we can't see. Also, the gateway, we're looking at how it can be used as a sample return facility. So if there are robotic missions sending samples back from the moon, Mars, or asteroids, they would have the option just to come to the gateway and then return home with Orion. So I'm actually, because I'd like to jump forward a couple of slides now to number 11. We're going to talk very briefly about a workshop that we held in Colorado, because clearly everything happens in Colorado, back in February. And this was a workshop where we wanted to engage the science community to introduce the gateway to them in such a way that they could really start to think about what science might they be able to use it for. The important part is we wasn't just sort of lunar and planetary scientists that were invited. We invited, there was the Earth scientists, the heliophysics, astrophysics, fundamental physics, life sciences, a broader community as we could reach. And we had roughly 300 people attend. And the real goal was to understand what science they would like to do, and to understand what would the gateway have to provide to help them to do that science. And if you go to slide 12, this just sort of summarizes the fact that we was well attended, a mixture of academia, government, industry, and international. We did refer to lessons learned from utilization on station, and then focused on how the gateway is different and the unique science that it would enable. And perhaps the last slide we'll cover today will be the top science takeaways, slide 13. And so based on this 3-day workshop, what we determined was that the gateway in the near rectilinear halo orbit does offer unique opportunities for some Earth, heliophysics, astrophysics, and fundamental physics investigations. To get really good lunar science, you're probably going to need additional transportation infrastructure. There was a lot of good lunar science that would like to be in low lunar orbit, not NRHO, or access to the surface. And so we're already looking at how we might be able to provide some form of reusable tug that could go from the gateway's orbit down to low lunar orbit and back. There was interest from the sample community who would like to mount sample collection material, sort of a bit like the Stardust and Genesis missions, onto the outside of the gateway to collect a wide variety of different materials, including cometary, solar wind, interstellar particles, etc. The fact that the gateway is outside the Van Allen belts and is in a true deep space radiation environment would make it a unique platform for the life science scientists to conduct experiments. And with that, perhaps we'll stop with the slides about halfway through your time, and then we'll go with the questions that you have.
All right, good. And I want to talk a little bit when we get through some of the questions about these different phases that you've got. So maybe we can hit that in a minute, but let me get to a couple of questions. So let's see. Upcycle electronics. How will the gateway manage life support on a periodic schedule? You mentioned that these will be from 30 to 90-day missions. Every other time it's going to be empty. Will visitors bring life support for each mission?
So the gateway will have regular logistics resupply missions, and that, like we said, will be driven by the timing of those crewed missions on once per year. And so when the crew is also delivered each year, they will bring additional logistics with them. Each of the habitats and the utilization module will have life support capabilities to support those missions. Orion will also augment those life support capabilities. In terms of the system dormancy, a lot of the work that's going on today in terms of developing, our lower level requirements and ConOps is looking at dormancy and how do we manage that on the gateway and how do we implement that. We're still early in our analysis and requirements and concept development. And so a lot of that is still in work, but it's definitely a priority for the development.
Okay, let me get to Raj. You're asking some good questions here. Raj Luthra is asking, first of all, what type of solar electric propulsion will be used on the gateway?
So if you want to go to back, we have had a chart on the power propulsion element, the first element. Not quite sure what you mean by, do they want to know exactly what fuel it is, or exactly what they're after? But it's, it's a very large solar electric propulsion, sort of 50 kilowatt class. It's actually a derivative of what we were thinking of using for the asteroid redirect mission, and it's a xenon propulsion system. And it has a 15-year lifespan. Slide 6 has quite a few of the details on it. It's the core part of the propulsion system of the power and propulsion element.
Okay, I have it up now. 2022 launch, 50 kilowatt class spacecraft with 40 kilowatt class electric propulsion system. So there you go, Raj.
Was he asking about the particular EP technology?
Well, there's a follow-up question. Is there any opportunity for Ad Astra Rocket Company to use their Vasimir on the Gateway?
So I think right now that might be one of the examples. The short answer to that is no. I mean, the solar electric propulsion system that we have for the PPE, it has two main goals. First of all, it gets this element to the moon, but then it also provides long duration power for all the modules. It also has the capability that it can move the entire gateway to different lunar orbits, such as the Earth-Moon L2 Lagrangian point. But right now, no, there aren't any plans to send different kinds of propulsion systems to the gateway to test it.
Okay.
And I was just going to add, the same way that we're working with our U.S. industry on the habitation implementation approach for Gateway, we've also been utilizing Next Step to engage our industry partners for their concepts for the power and propulsion element. And so that will be something that we'll be able to have more specifics on within the next 6 months or so.
Okay, what about refueling spacecraft? Did you guys touch on that? Will it be used in any way to refuel spacecraft on, like, for example, on the way to Mars?
So the Gateway will have the capability to be refueled, but the Gateway itself will not be a refueling infrastructure for the deep space habitat, at least in concepts that we had looked at previously, unless, Ben, you have other knowledge. But yeah, so no, it will not have the ability to refuel other spacecraft.
All right, well, okay. Larry Keys, have any of the microgravity growing food in space missions been booked yet?
Certainly, that's one of the items that the life science scientists are interested about. And that one of the things that's discussed at the workshop is how does the deep space radiation environment affect the nutrition value of foods and similarly the medicinal value of drugs, such that if you've got a Mars duration mission, you want to check that the astronauts are going to be getting the right nutrition that you planned on Earth and it doesn't degrade over time. So that is a good example of some of the experiments we envision could be conducted on the Gateway.
No bookings yet, though, to answer.
Yeah. And Tony, I've got a question. This is an excellent segue to a question I've got, or a two-part question that I've got. So I don't know if either Nicole or Ben mentioned this. According to current plans, this is part 1A. According to current plans, when does NASA expect the Gateway to be up and its first crew there? And then 1B, over years, say a decade of operations at the Gateway, is the expectation that the length of time that the Gateway will be crewed will increase with time to more, over time, duplicate the length of time of a Mars mission?
Sure. So the first element of the Gateway will be launched in 2022. That's the power and propulsion element. And then following the power and propulsion element, we'll have that utilization module as well as the Esprit. So those will be launched together in a single launch package. And those will provide the early crew capabilities as early as 2023. In terms of actual that will provide with the Orion initial 30-day missions for crew. And then as we continue to launch more habitation capability with the first habitation module, we'll be able to expand that beyond 30 days. But what we're looking at for the Gateway is primarily crew stays ranging from that 30-day initial up through 90 days. And so as we increase our capabilities, increase the amount of logistics that we have available to the crew, we'll be able to increase the crew duration and the crew time. As far as Mars mission durations, right now that's not in our current plans for the Gateway itself. It's just meant to be a short-term, short duration life support system and life support stays. And so, no.
So can I show this slide you sent on NASA exploration campaign? This has a timeline on it.
Yeah, this I have to note for the audience, as I mentioned earlier, I don't see the slides, so that the schedule may have been on the schedule may have been on the slides.
No,
so
it wasn't yet. I haven't shown it yet. I'm asking.
Well, I still haven't seen the slides, so still.
It's the number 21 is what you've got here. Can I put that up?
Yes,
Sure.
Okay, good. So I'm showing it now, and on it you have the top is listed as notional launches, and then you've got all of these different head lines or highlights. Maybe you could explain this slide for us a little bit.
Okay. Do you want to? You want me to take it?
I don't mind.
Okay. So at a top level, so as an implementation of the space policy that we have, expanding human presence again beyond LEO back to back to the lunar surface and exploring on the moon, NASA is implementing kind of a cross-cutting exploration campaign, working across the agency with our Science Mission Directorate and our Space Technology Mission Directorate to gradually advance our capabilities with small lunar landers, and then increasing that capability through various public solicitations, working with private industry, working with partners to increase that capability, increase the payload capability and size and lunar surface activity. Ben, do you think?
Yeah, so in the short term, I think we're in for a quite interesting few years. You'll see people are going to see lots of progress. So we're looking at something we refer to as CLPS, Commercial Lunar Payload Services, and that's going to be using small commercial providers to put instruments onto the lunar surface to do science and take key data. The idea there is NASA isn't going to be the only customer for these landers. We might be a significant customer, an anchor customer, but not the only one. And we're trying to grow that capability for that industry. And then, and that's being led by the Science Mission Directorate, whereas the Human Mission Directorate, we're concentrating on larger landers, initially in the 500 to 1,000 kilogram capability in roughly 2022, and then growing that so that it's scalable for human landers to the lunar surface later in the 2020s. And then you see at the bottom on this chart, also additionally to this, we have the Gateway with Orion and SLS and the deep space experience that will give us.
And this, the last slide you sent, this path to the lunar surface, this is sort of embedded into the overall campaign here. This is just the part from 2018 through 2026 that's going to get us through to the moon. Can I put that up?
Yes.
Okay, it's up now. And maybe this is, so you've got, we've got things going back from 2009 with LRO and then Artemis in 2010. We got Orion debuting in 2020. And then well, I'll just let you go ahead and talk about this a little bit.
Well, this is sort of what I just said, but with better graphics.
Right. But that's why I wanted to put it up.
A different visualization of the same graphic.
But if the audience are interested in the Orion, you might well like to pull up slides 18, 19, and 20, which describe the first Orion missions. And slide 18 has something called Exploration Mission 1 or EM1. This is uncrewed Orion mission that will go into lunar orbit and come back. And it's roughly a 1-month mission. We're going to take advantage of this on slide 19. And we're actually flying 13 CubeSats that will be released en route to the moon during EM1. And then the first crewed Orion SLS mission is EM2, which will do a loop around the far side of the moon and come back, and that's roughly a 9-day mission.
Okay, and you are relying. I think you might have mentioned this earlier, but I'm going to reiterate. You are relying on the Orion module for the human crew capsule, and then there's the SLS is the launch system you're going to use, right?
That is correct.
Okay, so this is all built with that in mind. Okay, let me All right. So there is. Let's see. We talked about refueling. It's not going to be used for refueling. And the science that's among the science that's going to be done, because this is happening outside of the Van Allen belts, as you point out. We really don't have any experience with long duration exposure to space other than what's on the space station, correct? We don't. I mean, other than when we went to the moon in the 60s and 70s, this is a brand new area for us, isn't it, as far as experience goes?
Yes, that's right. I mean, the Apollo missions are the only deep space human exploration experience that we have. We obviously have a lot of good robotic experience, but if you're talking about human exploration, then yes, absolutely.
That's a good kind of the secondary payloads. Some of the payloads that we have on EM1 have biological payloads. And so we're using EM1 to deploy those CubeSats, test the deep space environment on some biological payloads, and get those early results so that we can use those to inform the crew missions that are following.
And when you say biological payloads, what do you mean?
So one of the CubeSats, BioSentinel, will have active yeast cultures. And so it'll be the first time that a biological sample has traveled beyond LEO since Apollo. And so there'll be one on the SLS, so it'll be one of the CubeSats there, and then we'll have the control experiment on Earth, and that'll be sending data back for us on how the DNA responds to the deep space environment.
Okay, one plot, you're asking a question I don't understand. What is the maximum level of connections that the gateway can have? Oh, I get it. Okay, so you've got this thing designed as a module, little different connectors. So how big can this thing get?
So right now our configuration is what you see on slide 5. And just in terms of the attitude control and the mass controls of the gateway, this is what we are working toward, and that's how we're sizing the power and propulsion element to be able to perform orbit transfers on a gateway of this size. If we wanted to increase the size of the gateway, we would probably need to make some adjustments to the PPE, which at this point, kind of in where we are with acquisitions and looking to buying and building a PPE, is not really going to be possible.
And that also comes back to the refueling option. If you wanted to add a refueling option to that's a lunar lander, by comparison, is quite large so it would have quite an effect on the attitude control. So if we wanted to add a refueling capability, it's more ramifications than just a module with some fuel bladder on it.
And that brings up a question that I'd like to ask, another question. Human lunar landing, which of course is a really attractive capability out of the gateway. So what's the current thinking about, or opportunities working with American industry or with potential foreign partners, international partners, and so on, about using the gateway to stage human lunar surface missions?
So that is something that's being looked at right now, about how exactly the gateway is beneficial to humans to the lunar surface. I mean, there's various examples that initial thinking that's gone in to do, you could do things like send the descent stage down first to lunar orbit. Then the crew could leave the gateway in the smaller ascent stage, go down to low lunar orbit, dock with and they would have the gateway there as a safe haven, much closer than the Earth if they had a problem. So we are looking at how exactly the gateway feeds into the lunar surface transportation architecture.
Mm-hmm.
Upcycle Electronics has a good question. Let me this one has to do with the international aspect of this program. The NASA, I know, is always got a lot of international collaborators on a lot of things that it does. But Upcycle Electronics is asking, will other countries currently excluded from the ISS be able to participate in the Gateway mission?
Absolutely. And so where we are right now with our international partner collaborations, so our partners on the International Space Station, that was a natural pathway for us to explore, with the operational experience that our ISS partners have in building habitation capabilities, constructing large in-space systems with the ISS. We worked with our ISS partners to understand what kinds of configurations and concepts that they, working all together collaboratively, how we could build a gateway. with those agencies and with those partners. That being said, we are open to and there will be on-ramps for other interested partners, other agencies to collaborate and to join on the Gateway. A lot of the work that Ben and the utilization and science community has been doing for the Gateway is working with non-ISS partners to talk about through the science workshop about additional payloads, experiments, and different systems that could be used on a future Gateway.
Okay, now I lost your question, Peter Q, but I remember it as it scrolled by, and he wants to know about here it is. Is there going to be a new Canada arm? And to follow up, how did Canada get to be the arm expert? Did they go into this thinking, you know what, we're going to corner the robotic arm business? They did. And they did.
That's almost exactly
now, if you want a robotic arm, you got to go to Canada. It's like a monopoly. But anyway, are you going to get a new one for this?
Well, so you'll see on slide 5 that our baseline configuration right now does show a robotic arm. And, we're talking with our partners, we're talking with industry, trying to understand the best way to design that arm. Right now, you'll see that is going to, as we show, it's the pink color on the graphic. So we're looking to have that be an internationally provided element. And so, we found that has great utility for a future Gateway in terms of birthing modules, assisting with science experiments and payloads, and also supporting EVAs.
Okay.
Ben may know this better than I, Ben, but I believe 5, 6, 7 years ago, the Canadian Space Agency formally established space robotic arms as a priority for the nation. Of course, then they had to identify the industrial partner. We know who that is and so on. But they set robotic arms, robotic capabilities as a national priority for space exploration. Am I remembering that right?
Yes, I think you are, because as people will know, they provided the arms for shuttle and station, and so they have a lot of very good expertise in that area. So I think you are correct.
Okay, Asciano Vitale, you asked the question I was coming to next. Will it have any telescopes on it?
Oh, I know the answer.
So one of the outcomes of our workshop was to think about what science would be enabled by the Gateway, and in fact there was a lot of interest from a whole like earth scientists, heliophysicists, astrophysicists. Yes, a lot of interest in externally mounted cameras looking in all sorts of directions. So most people don't automatically think of sort of a Gateway around the moon as a good place to do earth science, and we were really pleasantly surprised by the response from that science community. They really like the fact that you can look at the full disk Earth from 400,000 kilometers away and see how things change over all phases. So just like you see new moon and full moon from Earth, you see a new Earth and full Earth from the moon, and that allows you to investigate, do science investigations. Even the exoplanet community were interested, because one thing to do is to have a camera on the Gateway. That how do you actually determine that Earth has life on it? You could do things like glint off the ocean, chirality measurements off forests. But the idea is having an instrument on the Gateway determining if you reduce the Earth to 1 pixel, how do you know there's life there? That could help potentially with developing the next generation of exoplanet cameras. And finally, the heliophysicists were interested in taking measurements from the Gateway of the Sun, because it's about a quarter of the distance to the Discover satellite, and there was definite interest in science that you would do from that distance. So yeah, I suspect there'll be a lot of telescopes on the outside of the Gateway, covering a wide variety of the electromagnetic spectrum.
That's an interesting idea with the exoplanets, because of course you'd want to get some sense of what Earth might look like as an exoplanet from a distance. And so this would be a good way where you could get the reflectances of the different kinds of vegetation and things like that from slightly far away. It would also be a good thing to do from the L2 point, but that's a different topic. So let's see. Adam Synergy, sounds like the astronauts will be busy throwing CubeSats out the airlock. maybe. Susan Hunter, they did mention the Bigelow expandable modules, and that is a part of the plan. We talked about that earlier on. So yes, that is part of it as well.
Just to be clear, it's a possible.
It's one of the investigations.
Yeah.
So we're still working with our 6 partners under Next Step to determine how we will implement.
Okay, well that brings me to the point I want to bring up now before we leave, and that is this is a serious thing NASA is going to do, or are you just planning on seeing what's possible and what we can maybe get some companies to do and what it would look like if we could do it? In other words, is this an actual funded thing that NASA is going to do?
This is a serious thing that we're doing. The power and propulsion element, like we mentioned, the draft request for proposals went out this summer, and the final solicitation for that procurement will go out this fall for the U.S. companies, and we will begin the procurement and building that next in 2019. And so that will be launched in 2022. So the first element of the Gateway is the real deal.
Only 4 years away.
Yeah.
Awesome.
And when will you select the industrial winner?
So that's a great question. So we're using Next Step not necessarily to down select to one company and select their concept for implementation for the Gateway. As you mentioned, so the Gateway you saw with all the colors and the different modules, the implementation of Gateway is going to have multiple providers. And so we'll have a domestic provider for that PPE, which will be selected through the solicitation process. For the robotic arm and one of the habitation modules and the Esprit, that will be internationally provided. And so what we have our domestic partners looking at right now is investigating concepts, not just for a single module on the Gateway, but for a full what is their configuration and concept for a Gateway. And so what we're going to do through those ground tests and through those prototypes is evaluate each of those Gateway configurations and kind of tease out what implementation approach or what company's implementation of a particular subsystem or a structure or a configuration inside the habitat makes the most sense for meeting the requirements and concept of operations that we're defining on the NASA side for what we think a Gateway should be able to do. And so I think what you'll see in the next couple of years is not necessarily a winner or a down select of one provider of a Gateway and a building of that, but a selection of a lead for the U.S. habitat, a lead for a particular subsystem or element or module, but there won't be one company or agency that provides all of it.
Okay, let's see. I just lost the question I was going to ask. What is one plot is commented that he is going to corner the space doorknob market. You go right ahead. One plot. You do that, and who knows? It might be the next space billionaire. Let's see. One plot. What is the life expectancy of the Gateway? Will the life expectancy of the Gateway be affected by the radiation, or can it last like the ISS?
So each element of the Gateway, requirement for each element is that it needs to have a minimum of 15 years of on-orbit lifetime. And so what that means is, the short answer is no, there is not an end date or a lifetime for the full Gateway system. But as these elements reach kind of that 15-year minimum lifetime requirement, we'll do the same thing that's been done on Space Station 2. What maintenance needs to be performed, analysis of upgrades or systems that need to be refurbished or refined. We want to always maintain that continuity of human spaceflight, and so I don't think you'll ever see a Gateway being abandoned in cislunar space, or we want that to be a core part of our deep space infrastructure. And so, we're making sure that the requirements that we're building today will be sustainable to make sure that we are really and truly building that deep space presence that's sustainable and can sustain.
Oh, good. And in a related then follow-up question, I'm going to ask Raj Luther's question, which is, once the ISS is retired, what will happen to it? I suggest moving the ISS to the Lagrange point for a later use, and if not useful, create an area where it can become a museum. So we've already talked about what it's going to take to move it, so that's not really going to happen. Getting it to the L2 point, I think, is like, yeah. But the basic point of what will happen to the ISS once it's retired, I mean, there was talk about, I believe the Trump administration wants to privatize some of the ISS. We've got funding, or NASA has funding for us up to a certain point, and then it doesn't. What's going to happen to the ISS?
So, one of the things we've been tasked to do is to look at commercialization. How can we allow station to be used by industry? One thing to remember is you can't just take station to a higher orbit and leave it. It's different technology to the Gateway in that it does require a crew to be on board to keep it running. So I think NASA's been given the task to work out how it cannot be the only user of station, and so we are currently looking at how to implement that by the time frame we've been given. Even if station were to go away entirely, we envision that NASA will always have a need of doing things in low Earth orbit, which was why slide 3, talked about a potential future commercial LEO platform.
Okay, all right. And let's see, Larry Keys is asking, our systems engineer is implying that NASA will be the systems engineer for the Space Gateway. Is that true?
Yeah, that's correct. On slide 5, you'll see that we have, while we'll have U.S. providers, international providers for different elements, NASA is going to maintain its role as the lead architect and integrator for the Gateway.
Okay. And finally, I'll just leave Raj Luther's question. Do you have any details on the deep space transport?
So the deep space transport was or is envisioned to be ultimately the system that provides the transportations from for humans from cislunar space to the Mars system. We have, we're refocusing a lot of our activities on how we can, bring humans back to the surface of the moon, how we can use the Gateway and establish that infrastructure so that we can expand that human presence, implement a lot of the lander activity that we're working with industry and within NASA and our partners on. And so the deep space transport has always kind of been a later phase activity, but we're still, we have our eyes on Mars, and we want to make sure that any system or capability that we're building today with Gateway or lunar surface systems, that we have extensibility of those systems to future Mars systems.
Awesome. Okay. Well, we will. I guess we will stop it there. I want to thank our guests, Nicole. Nicole Herrmann and Ben Bussey from NASA HQ, talking to us about the NASA Gateway. It's not supposed to be the Deep Space Gateway, it's the NASA Gateway, and we've got a lot of exciting stuff coming up with human spaceflight, in particular with NASA's got planning in the coming years leading up into the middle of the next decade. So we'll keep in touch. I hope that you guys might consider coming back and giving us some updates as things progress and as things get done, because this is awesome. This is, I think, a great program, and I'm keeping my fingers crossed everything happens exactly as we hope. And so thank you both very much for taking time out to be with us. Harley, do you want to talk about the next one, or are we still working on the plans for the next?
We have scheduled topics actually right through October, I think into November, and I don't have the schedule.
Yeah, I know. Unfortunately, I'm better at this. But next week, I do know what's happening on the Astro Coffee Hangout. We will be talking with Dr. Adam Frank from the University of Rochester, who has written a paper on the fact on whether or not climate change might be a great filter for civilizations to be able to populate the galaxy. And so we're going to be talking about them with their research next week. That's next Thursday on Astro Coffee Hangout, and Carol Christian may or may not be here. She's currently going to the IAU, I think, and so she won't be available, but we'll see. Anyway, on behalf of my guests, I want to thank you all so much for watching. This is something you get every Thursday, courtesy of the American Astronautical Society and the American Astronomical Society. They both endorse and support these Hangouts. So thank you very much to them. Please check out their website. If you want to be notified on all of these new Hangouts, if you go to deepastronomy.space, you click on register, you enter your email address, and that's all we'll ask you for. We will notify you for future Hangouts as well as new content that comes out. So thank you all for doing that, and you'll get absolute reliable notifications each time. All right, so on behalf of Harley Thronson and my guests, I want to thank you all so much for watching. And as always, keep looking up.